Science Nonsense. Today, let's discuss about the operating system generation. Introduction to operating system generation. Operating system generation refers to the process of creating and configuring an operating system tailored to specific hardware. It involves selecting and compiling the necessary kernel components and system libraries. This process ensures that the operating system can effectively manage resources and services for user applications. Historical context. The concept of operating system generation emerged in the 1960s as computers became more complex. Early systems required manual configuration to support different hardware setups and user requirements. This need for customization led to the development of more operating systems over time. Key components of OS generation. Operating system generation includes the kernel, device drivers, and system libraries. Each component must be compatible with the specific hardware architecture being used. Proper integration of these components is essential for system stability and performance. Types of operating systems. Operating systems can be categorized into batch, time sharing, and real time systems. Each type serves different purposes and requires distinct configuration approaches. Understanding these categories is for effective operating system generation. The types of operating system are multi-programming batch operating system, time-sharing operating system, multiprocessors operating system, mobile operating system, real-time operating system, distributed operating system, networking operating system, and simple batch operating system. The batch processing systems. Batch processing systems execute jobs in groups without user interaction. They rely on an operating system that can efficiently manage job queues and scheduling. The generation of such systems focuses on optimizing throughput and minimizing wait times. Time sharing systems. Time sharing systems allow multiple users to interact with the computer simultaneously. These systems requires a well-configured operating system to manage resources dynamically. Proper OS generation ensures responsiveness and fair resource allocation among users. The role of configuration files. Configuration files are essential in the OS generation process, dictating system behavior and resource allocation. They allow system administrators to customize settings without modifying the code directly. Proper management of these configuration files is crucial for effective operating system performance. Compile time versus runtime generation. OS generation can happen at compile time, where code is built for specific hardware. Alternatively, runtime generation allows for dynamic adaptation based on current conditions. Understanding these methods aids in selecting the right appropriate environment for the OS generation. Automated tools for OS generation. Modern operating system generation often utilizes automated tools and scripts. These tools can streamline the process, reducing human error and saving time. Automation enhances consistency and reliability in system deployment. The challenges faced in OS generation. One significant challenge is ensuring compatibility across diverse hardware platforms. Maintaining security while generating an OS is critical to protect against vulnerabilities. Additionally, managing updates and patches during the generation process can be complex. Data security consideration in OS generation. Security is a paramount concern during the operating system generation process. Configuring security features such as user authentication and access controls is essential. Regular updates and patches must be integrated into the OS to defend against the emerging threats. Testing and quality assurance. Through testing is necessary is to ensure that the generated operating system functions as intended. Quality assurance processes help identify potential issues before deployment. This stage is vital for maintaining system reliability and user satisfaction. Documentation in OS generation. Proper documentation is crucial for understanding the configuration and management of the operating system. It provides guidelines for troubleshooting and feature updates. Comprehensive, comprehensive documentation improves collaboration among developers and system administrators. Now, let us discuss about the future trends in OS generation. The rise of cloud computing is influencing the way operating systems are generated and deployed. Containerization and virtualization technologies are changing traditional OS generation practices. Future trends may focus on increased automation and AI driven configurations. Now let's see the case study on Linux OS generation. The Linux OS generation is a prime example of a flexible and customizable operating system generation process. Users can compile the kernel and select modules based on specific needs and hardware. This adaptability has contributed to Linux popularity in various environments, from servers to embedded systems. The role of open source in operating system. The benefits of operating open source software development in the OS. Open source software plays a significant role in operating system generation by providing accessible code. It encourages collaboration and innovation, allowing users to modify and enhance the OS. The operating open source model fosters vibrant community that contributes to the ongoing development and improvement of the OS. It helps in the seamless compatibility, documentation, flexibility and agility and also security of the OS operating system. Coming to the conclusion of today's presentation on OS generation, operating system generation is a critical process that shapes the performance and capabilities of computing systems. Understanding the nuisance of OS generation can lead to better system design and management. As technology evolves, so too will the methods and tools used in the operating system generation. Questions and discussion. Open the floor to questions regarding operating system generation and its implications. Encourage discussion on personal experiences with OS generation and challenges faced. Gather feedback to understand areas of interest for further exploration. Coming to the references and further reading, list key references and resources for further exploration of operating system generation. Include textbooks, academic papers, and reputable online resources. Encourage attendees to delve deeper to the subject for more comprehensive understanding. This presentation covers various aspects of operating system generation, ensuring the comprehensive understanding of the operating system generation. So this was my presentation on operating system generation, guys. Hope you all liked the video. Thank you for watching.